Hello there and welcome to Lower 6th Further Maths A-Level. This is the core part of the syllabus and we're working on the specimen paper here. So question 5 looks like this. We have a polynomial here. We have half minus root 3i as one of the roots of the equation. Write down the other complex number. Well, that's obviously going to be its complex conjugate. Half plus root 3i, or I root 3, doesn't really matter. Using algebra, solve f of z equals 0 completely. Okay, so what I'm going to do here is that nice method where we undo the completing the square. So I know that z is either equal to half plus or minus root 3i. So what I need to do now to undo completing the square, I need to take away a half on the other side. So now I've got plus or minus root 3i on both sides. Square both sides, so I've now got z minus a half squared on the left. And if I square the right hand side, the plus or minus will disappear. Squaring root 3 will give me 3, and squaring I will give me a minus 1. So it's minus 3. Expanding these brackets, I get z squared minus z plus a quarter. And plus 3 onto the other side, and I get this. Simplifying z squared minus z, simplifying this bit here, I'm going to get 12 over 4 plus another 1, that would be 13 over 4. And seeing as my original formula here doesn't have any fractions in it, I'll times through by 4, I'll get 4z squared minus 4z plus 13 equals 0. Now I need to think what's the other root going to be. Well, if I've got 4z squared minus 4z plus 13 and then need a third root here that will then expand my brackets to give me this, I can see I've got an 8z cubed, so I probably need a 2z at the front of this. And if I've got a 13 at the end with a plus 65 here, I probably need a plus 5 here, so that when I expand my brackets I get plus 65. Let's just do a mental check for 12z squared. So I'm going to have 4z squared times by 5, that's 20z squared, and minus 4z times 2z, that would be minus 8z squared. So that will give me 20z squared minus 8z squared will give me 12z squared. And you can do the same thing for 6z as well. Alright, so use algebra to solve f of x completely. So z is either equal to half plus root 3i. Z is also equal to a half minus root 3i. Or z is either equal to minus 5 over 2. So those are the three roots. Show them on a single Argand diagram. So let's make this nice and clear. Minus 5 over 2 is going to be over here. Let's label them. Half plus root 3i will be up here. And a half minus root 3i will be symmetrically down here. Okay, part D, show that the roots form the vertices of an equilateral triangle in the complex plane. So what I've got to do is prove that this line from here to here is the same distance as the line from here to here, and is the same distance as the line from here to here. Okay, so from here, let's label them so make it easier for us. A, B, and C. So A to B, distance from A to B is, well, it's not moving left or right by anything. It's just moving from root 3 down to 0, down to minus root 3. So the distance there is 2 lots of that root 3 distance. Okay, from A to C, I'll probably need to bring in here a little right angled triangle. So I'm going up to root 3, and I'm going from minus 5 over 2 to positive a half. So that's going to be a distance of 3 here. So it's going to be the square root of 3 squared add root 3 squared. which is going to give me 9 plus 3, which would be the square root of 12, which is 2 root 3. Perfect. And I can assume that b to c is going to be exactly the same thing. It's just the triangle upside down. So I'll repeat my workings. And that equals 2 root 3. So all sides equal 2 root 3. And there we are, that's the answer for question 5, that's 8 marks.